In this recording, I'm going to do the solutions for assignment 34, at least for most of the problems. Let's look at number 1 here. Determine the symmetry of the following functions. So here we're going to use what's called the algebraic test, since we don't have the graph. And so on number 1, we want to plug in minus x for x as an input. And when we do that, we're going to end up getting, let's see, minus x cubed will be a minus x cubed. A minus x squared is just the same as x squared, so that's plus 3x squared. And the last term will be plus 4x. And so if you look at what we had for f of x versus what we have here, two of our terms have changed signs, but the 3x squared did not. So remember, if f of minus x equals the original function, we have y-axis symmetry. We don't have that. And if f of minus x equals the opposite of the original function, or minus f of x, then we have origin symmetry. Well, that's only true if all the terms change signs, and only two of them did here, so this has neither kind of symmetry. Let's look at number 2. Let's go ahead and plug in minus x. And of course, minus x to the 4th power, that's an even power. That's just going to equal x to the 4th. And so here we are equal to the original function. And so this is a case where we have y-axis symmetry. Now if we look at number 3, this is a quadratic function. And so the kind of symmetry we're going to have here is symmetry with respect to the axis of symmetry. So let's go ahead and use our negative b over 2a. We're going to get negative 4 over 2 times 1, since we have 1x squared. And that's going to equal negative 2. And so our axis of symmetry is x equals negative 2. Notice number 4, it says, describe the behavior of the following functions at their x-intercepts. Well, this problem's in factored form, so it's easy to know the zeros, or x-intercepts. Whoops, I'm sorry, I forgot to put that in at the top there. Let's go ahead and make our table here. So our x-intercepts can be found based on our factors. If x plus 6 is a factor, then that means negative 6, 0 will be an x-intercept, or we could say negative 6 is a 0. And the multiplicity, because of that 3 there, the exponent is 3, so our multiplicity is 3. Since we have odd multiplicity, we know that we'll cross at that intercept. And then our next one would be 7, 0. And here we have an even power of 4. And so here we're going to bounce. And then our last intercept is at 2, 0, which has an exponent of 1. The x minus 2 has an exponent of 1. So the multiplicity is 1, which means we're going to cross. Let's move on to number 5. So we can factor this as x minus 4 times x plus 4. So let's go ahead and make the table. We have two x-intercepts, 4, 0, which has a multiplicity of 1, and so we're going to cross, and negative 4, 0, which also has multiplicity of 1, and again we'll cross. On number 6, we're going to have to factor what we have there first. We can factor out an x squared, and then if you use the AC method to factor what's inside the parentheses, this one's not too bad. You get x plus 3 times x plus 3, which can be written as x squared times the quantity x plus 3 squared. So here, let's go ahead and make our table. We have two x-intercepts. The first one is 0. We learned that if x is a factor, that 0 is a 0. Notice the multiplicity here, because of the x squared, will be 2. Which means we're going to bounce at that intercept. And then the other intercept will be negative 3, 0, which also has a multiplicity of 2, and so we're going to bounce there. Let's move on. So on number 7 it says determine the end behavior of the following functions. So on number 7 the leading term is x to the 6th, so our degree here is 6. And we know that any polynomial that has an even degree is going to have end behavior where it goes up on both sides or down on both sides depending on the coefficient of the leading term, which here is positive 1, and so it's going to open up on both sides. On number 8, our leading term is the x squared term. So our degree here is 2. Notice we're negative. Our leading term is negative. I should say the coefficient of the leading term is negative. And so here, this is a parabola that opens down. And any even power that has a negative coefficient would be the same. And then we've got one more here. This is got a leading term of x to the 7th, or minus x to the 7th, so our degree is 7. And we're negative, so this one's going to be the opposite of the John Travolta, or what we've been calling the John Travolta. It's got a negative coefficient, and so it's going to look like that. And now let's move on to number 10. It says solve the following polynomial inequalities. Write your answers in interval notation. So on number 10, first of all we're going to need to find our x-intercepts. So we'll need to factor this using the AC method. Two numbers that multiply to -12 that add to -1. That's going to be 3 and -4. And so we're going to get zeros at -3 and 4, which means we have corresponding intercepts at -3, 0 and 4, 0. Now notice here we're including our zeros in our solution because of this equal sign in the less than or equal symbol. So let's go ahead and put our points on the graph. And let's see, our end behavior, if you look at x squared, it's positive 1x squared. So it's going to open up on each end. So let's put that in. And notice we're crossing each intercept. This is actually the kind of graph we're expecting to get when we graph a parabola. Notice we didn't need the vertex to do this. And so finally we're looking to shade below, since we want to know when x squared minus x minus 12 is less than or equal to 0. So let's shade below. And so our solution is going to be basically for all the x values between -3 and 4, this value is the value of the function is going to be negative or less than 0. So we'll write our answer as the interval from -3 to 4, including the endpoints. Let's go ahead and move on to number 11. We can factor this one pretty easily. We got a difference of squares we can factor there. So we can rewrite this function in factored form. So we know our zeros, which tells us where our x-intercepts are going to be. And let's see, in behavior, notice we have x cubed here. Let's see, let's put in open circles on our zeros here. Now the end behavior is going to be based on x cubed, our leading term, which has degree 3. So this is going to have the John Travolta end behavior, or really the graph of y equals x cubed. It's going to have that kind of behavior. So let's put that in. And then we are going to cross at each 0, since each of these factors has a degree of 1. And so there's our graph. We want to know where we're greater than 0. That'll be above the x-axis, so we want to shade up there. And so when x goes from -1 to 0, we're positive. And also when we're at 1 or greater than 1. And so that's our solution. Let's move on. On number 12, first of all, we can simplify this by just subtracting 2x squared and 4 from each side. So we get a lot nicer looking polynomial. And we could factor this using the AC method. So the numbers that are going to work are 1 and -4. So we get x plus 1 times x minus 4, which means we have zeros at -1 and 4. Notice we have an open circle here because strictly less than is what we're interested in. There's no equal sign there. Again, our end behavior, since we're x squared, is going to open up on both sides, and we're going to cross at each 0 since our factors had exponents of 1. So we want to know where we are less than 0, and basically I just want to point out we're really just graphing this one over here. It's just a simplified form of the original problem. So we're wanting to shade below since it's less than, and so our answer is going to be from -1 to 4. Alright, last problem for this first video. So notice here we're going to be sketching a parabola. It says determine the end behavior. Well, x squared is our leading term, and so we have degree of 2, and it's positive, so we're going to open up on both ends. To find the zeros, we'll set this equal to 0. Or actually, we'll just factor it. And we get x plus 2 times x plus 6, so our zeros are -2 and -6. And so our x-intercepts, also we're going to cross at the intercepts here. So our x-intercepts are -2, 0 and -6, 0, and we're going to cross at each of those. So that's enough information to graph this. Let's go ahead and plot our intercepts and our end behavior. And then we know we're going to cross at each intercept. In fact, we know we're going to get a parabola here. And again, we weren't asked to find the vertex here, so we're not going to worry about that, but we certainly could. We could use our x equals -b over 2a. But this is good enough for what they were asking for. Alright, so we're going to stop. This is part 1 of our solutions. The other part will finish things out.